Lesson 59 actually has 3 main topics, and we are only doing the first 2 today. We'll talk about solving systems when you have both fractions and decimals in them. Basically, that's just review. We'll also talk about how to change from rectangular to polar form. You've been doing polar to rectangular. We're just going to go the other way, and I'll throw in the shortcut formula for when you're doing polar to rectangular now that we've had some experience with that. The other topic we will do tomorrow, finding the line of best fit or linear regression. And we'll be doing that with calculators, and then we'll be practicing that through the rest of the week until we have our test on Friday. So first, if we have something like this messy looking system, it's got fractions and decimals. And when you see something like that, what's your first reaction? What do you first think? What do you really want, Evelyn? I could do that, but how many of you just love decimal problems? My favorite problems are just plain integer problems. How about you guys? So, do I have another choice? If you have decimal equations, do you know how to get rid of decimals? Yes? No? Yeah? So you can multiply decimal equations by powers of tens. You can multiply fraction equations by the least common denominator. My first reaction is, I'm going to get rid of the fractions and decimals. I like integers better. So that's what we're going to do. So everybody, what is the least common denominator for the top one? 10, so we're going to multiply everything by 10. 10 over this 2 becomes a 5 times the x in the numerator, plus 10 over the 5 here becomes a 2 times the plus 3y becomes plus 6y, and then we have negative 20 over 5 is a negative 4. To clear decimals, we multiply by powers of 10, or we move all the decimals the same number of places. So how many places, Dave, do I need to move my decimals on that second one? For the second equation, the decimal equation, how many decimal places do I need to move all those decimals? Need to move everything 2 places, because that's the most decimal places that I see, which means I'm multiplying this one by 100 to do that. So move that 2 places, and I have 6x. This one I have to be careful on. I have to put the 0 placeholder in there, so that when I move that one 2 places, I have minus 20y. And then this one, when I move it 2 places, I have 104. So now I have a system with percentages. If I do it substitution and try to get x equals or y equals, I'm going to be back to some messy fraction things. And I don't want that. So I'm going to do this one with elimination. Show of hands. How many want me to get rid of the x's? How many think it looks easier to get rid of the x's on this one? To get them to cancel out. How many think it looks easier to get rid of the y's? All right, you're surprising me. Y's, I've got to get the 20 and the 6 to cancel out, but we'll do it that way. I've done it the other way with the other classes. So that means, let's see, what do I need to get those to be? Plus and minus 60y. So that means let's multiply the top one by 10 and the bottom one by 3, and that will give me plus and minus 60, right? So check the work here, since I don't have it this way on my notes. 50x plus 60y is negative 40. Does that one look okay? And 18x minus 60y is 312. So let's see, 68x, and then the y's canceled. Positive 2 minus 0 is 2, 31 minus 4, 272. And then I need your help. You guys have the calculators. If I divide both sides by 68, what do I get? 8x? 4. Others getting 4? Okay, always good to double check each other. Now I need to plug that 4 back in one of my equations. I could go back to my original fraction and decimal equations, but then I've got to deal with doing arithmetic with fractions and decimals. So instead, I think I'm going to pick one of these two. I'm going to pick the top one because 6 is smaller than 20 and 4 is smaller than 104. And I like smaller numbers. So I'm going to say 5 times the 4 is 20, plus 6y is negative 4, and if I subtract 20 on both sides, 6y is negative 24, so everybody, what's y? Negative 4, so we know our answer is 4 comma negative 4. Anybody with a question on how that works? Just do what you know how to do and get rid of the fractions and the decimals, and then solve it whatever way you think is the easiest way to solve the system. All right, moving on to converting vectors from one form to the other, this time from rectangular to polar. The process is the same as what we've been doing. Start off, draw your picture. Draw your x and y axis. Then draw negative 3, so I need to go 3 to the left. Plus 5j, so I need to go 5 up, so I'm in the second quadrant. Draw my vector. Still draw the triangle. It still has to have one side as part of the x-axis, so I have to draw a vertical side so that this side is part of the x-axis. I can never go to the y-axis. Label what I know. What I know is I went 3 this way, and then I went 5 that way. I want to write it in the other form, which means I want r at theta, and r is the hypotenuse, so I need to figure out the hypotenuse for that triangle, and then I'm going to need this angle theta from the positive x-axis. So let's start with side r. I have a right triangle. I know 2 sides of the right triangle. How do I get the third side of a right triangle, Nicole? Pythagorean theorem. So we can start off by saying that r squared is 3 squared plus 5 squared, which means r is the square root of that 3 squared plus 5 squared, and 9 plus 25 is 34. So r is either the square root of 34, or if we decide we want a decimal, 5.831. Now the angle that I need is not inside that right triangle that I've drawn, correct? So I'm going to use the same kind of reference angle that I've been using, the angle that's inside the triangle with a vertex at the origin would have to be this little angle here. With right triangle trig, for that angle, which trig ratio should I use for the 5 and the 3? Amelia? Tangent, because it's opposite and adjacent. So I can write down that the tangent of rho is the opposite over the adjacent, 5 over 3. Since I need an angle, take the inverse tangent of both sides and be sure inverse tangent goes on the left and 5/3 goes on the right. And now punch that into your calculators to help me out here with this problem. And raise your hand for me when you have figured that out. Mateo, what did you get? 59 point what? 0.036 degrees. So if I say my vector is root 34 at 59.036 degrees, does that match where I drew this green vector? If I say it's at 59 degrees, I'm saying it's in the first quadrant. But my picture shows me it needs to be in the second quadrant. So it is not correct to say root 34 at 59.036 degrees, because that one is in the first quadrant and our picture is in the second one. So what you need to do is to use the geometry in your picture and tell me a relationship between where I wrote rho, which is the one that looks like a P, and theta, which is the one that I really want. If you look at this picture over here, can I add them? Can I subtract them? Get something else? What is the relationship? Coleman? Everybody good? When you look at that picture, rho plus theta is 180. They are supplementary. So we write that down. Rho plus theta is 180, which means theta is 180 minus rho. Now, there's several ways you can do this on your calculator. Your calculator right now has 59.036 on the right. You can say times -1 to make it have a minus in front of it, and then do a plus 180. You can store that. I'd store it as P, since rho looks kind of like a P and we only have English letters on our calculators. And then do 180 minus your stored P. You can do that. You can say, oh, well, if I just do rho minus 180, I'll have the opposite of what I want. So you can just do minus 180, but only write down the positive answer that you get. Do whichever one of those three ways makes the most sense to you, and raise your hand when you have figured out for me what theta needs to be. Grayson? 0.964, is that what you said? Is that what others got? Look at your picture. Does that make sense? Does that match being in the second quadrant? So then you would write your final answer as either root 34 at 120.964 degrees, or if you wanted the rounded decimal, 5.831 at 120.964 degrees. Anybody with a question on that example? Okay, a couple of things before we move on. It is not always 180 minus rho. This is different in every single quadrant, a little bit. You have to look at the picture and say, for this picture, how does the geometry fit together to figure out your real angle? Does that more or less make sense? We'll do another one here in a minute where it's a little bit different strategy. Also, let's make some observations here. Notice when I did R was the square root of 3 squared plus 5 squared. That was the square root of my I hat squared. Well, I really don't care if it was negative or positive, because when I square it, it's going to be positive. That was my I hat value squared plus, and the 5 was my j hat value squared. So if I want R, I can either set up the Pythagorean theorem and derive it like we did, or I can memorize the formula that we'll write down in a moment, that the magnitude is the square root of the I hat squared plus the j hat squared. Also notice when we did that rho was the inverse tangent of 5 over 3. Whenever we draw these pictures, j hat is always going to be the vertical part. No matter which quadrant we're in, the vertical part is always going to be opposite. And the I hat part is the horizontal. No matter which quadrant I'm in, that's always going to be adjacent to my angle. So this was the inverse tangent of the j hat over the I hat, except that I only worried about the positive values of that. I didn't really want any negatives in there, so that's why I'm going to put the absolute value in there. So summary in words and then in the formula list. Draw the vector just like you've been doing, going the other way with your conversions. This time, you don't know the hypotenuse, so you need to find that using the Pythagorean theorem. You need to use the tangent ratio to find the reference angle, and rho is always the one that is in between 0 and 90. Theta is the real one that's anywhere between 0 and 360. Once you have that, you figure out that real one between 0 and 360 by looking at the geometry of the picture. And finally, you just write your final answer. So if we put that into our formula list, we have just said that to get rho, which is our reference angle, it is the one that is between 0 and 90 degrees. We take the inverse tangent of the vertical over the horizontal, the j hat over the I hat. That would be the opposite over the adjacent. Absolute value means we ignore any minus signs in that. R is the magnitude or the length of the hypotenuse of the vector. And we used Pythagorean theorem on that, so it was the square root of I hat squared plus j hat squared. You may memorize and use the formulas, or you may derive it on each problem. A little faster if you memorize it. Final step then, theta, the real angle. You look at the geometry of the picture. And theta is somewhere between 0 and 360 degrees. I will use these formulas on our last example of this today to model how you can do it a little bit faster, but if you need to still derive it each time, that's okay. So first up, I wrote this one down with the R and the U because you're going to see it like that in your book. But remember, I don't want you to even copy it down with the R and the U. You would immediately look at this and write down, oh, I need to do minus 3 I hat, minus 5 j hat. So it's going to be very similar to our first example. I've still got a 3 and a 5 in there. It's just a different font. First, we draw the picture, so draw the x and y axes. Negative, negative means this time we're going to be in the third quadrant. So go 3 to the left, 5 down, draw that vector, something like that. Is this okay then for my triangle? Why not, Riley? Well, the vector still goes to the origin. But what's wrong with the way I drew the triangle? Sabrina? I've got to have one side of it as part of the x-axis, not the y-axis. I've always got to draw a vertical side to complete my triangle. So now I have one side that is part of the x-axis. Label what I know. I went 3 this way and 5 this way. I need to get the hypotenuse. So my formula says that the hypotenuse is the square root of I hat squared plus j hat squared. So I don't really care about the minus sign. 3 squared is 9. 5 squared, or negative 5 times negative 5 is 25. So I still have square root of 34 like I had on the last one, since I'm still using 3 and 4. And so we said that decimal was 5.831. Okay, I also need to get my angle that goes all the way around to here. But that's bigger than 180, so I can't do that with right triangle trig. So what I have to do is I have to get the reference angle, which is inside my triangle, with a vertex at the origin. One side is part of the x-axis, one side is my vector. My shortcut formula says rho is the inverse tangent of j hat over I hat. Don't worry about the negatives. So rho is the inverse tangent of my -5, but I'm not going to worry about the minus. I'm just going to say 5 over my I hat, -3, but I'm not going to worry about the negative. I'm just going to say 5/3. Oh, that's exactly the same as what we just punched in on our calculators on the other problem. So our calculator still shows us that that is 59.036 degrees. If I hadn't memorized my new formula yet, I would look at this picture and say, oh, the tangent is opposite over adjacent. The tangent is 5/3. So I need rho to be the inverse tangent of 5/3. See how you could do it whether you've memorized the new formula or not. Now, if I say 5.831 at 59 degrees, I'm in this first quadrant. That's not where I want to be. If I do 180 minus rho, that's going to put me in the second quadrant. That's what I saw before. Tell me what I need in this picture. Look at the geometry. Remember that rho is just this little part right here. I need to end up with that red part all the way around. Look at the picture and tell me a relationship that you see. And you are looking at that. How can you put different things together there? Rick? So does that make sense to everybody? That's 180 right there. So if I put my black 180 with my purple rho, do I get just as far as the red one all the way around to there? So I can say that for this one, theta is 180 plus rho. The last one it was 180 minus rho. You see how it changes a little bit from quadrant to quadrant. So if I take this stored 59.036 and add 180 to that, what am I going to get there? To 39.036, I think. Final answer, I have to write it at theta form. So root 34 or 5.831 at 239.036 degrees. And you do have to have the degree signs in that. Anybody with a question on that example? Right, final thing we're going to add to the formula list are shortcut formulas going the first way when we start off with polar and we want rectangular. So, if we have a general picture like this, these are the ones we've been doing for a number of days now, we know then polar to rectangular, so we know R and theta. So we figure out rho from the geometry. And then we label our picture that we've drawn, and then we write down cosine of rho is adjacent over hypotenuse, sine of rho is opposite over hypotenuse. Solve it for I hat and j hat, and we have I hat is r cosine rho and j hat is r sine rho. I hat is always the horizontal part, So it's always the adjacent, so we will always have an I hat when we write down the cosine. J hat is always vertical. So these are our formulas, and you can now skip writing this step if you want to. You can still write that out if it helps you to say, okay, cosine of 32 degrees, cosine of 112 degrees, or whatever you've got equals, side over side, or you can go straight to this. So these are your formulas for I hat and J hat. And again, you find rho from the geometry. Rho has to be less than 90 and more than 0. And that finishes up today's work.